Welcome, everybody. I love that. Rockford, Ohio, William Miller, Miller Consulting. See, Donnia's got a fan club. I love that. Everybody loves Donnia.
Yeah, Jamie works with us. She's out in the Midwest.
Give them another minute here. If you just joined, we were just asking for people to put where they're tuning in from in the chat. I want to see who is the farthest. I think Long Island, New York is the furthest so far. Hello, Atlanta, Georgia, Ashley.
Yeah. Ashley and Ellen,
Texas.
Two more of ours, yes.
Oh, we're getting a lot of Georgia. Augusta, Georgia, Ben Rucker. Hey, Alex, there's somebody else I know. Seattle. Here for the CAD mama. Marshall, Minneapolis. I hope it's warming up there. That was always the thing with me when I go to Minnesota. I'd always end up there in December or January. All right, well, thank you, everybody. We're excited. Oh, yes, definitely. Good time to ice fish. Thank you for that comment. Let's kick this off. Welcome to the new community conversations. These are hosted by the Autodesk community. Our community conversations are the new live virtual events designed to allow to give you expertise, connect with leaders, and grow your community network. My name is Sean Hurley. I'm a community engagement manager at Autodesk, and we are joined by the talented Donnia Tabor-Hanson. I'll be your community host. I'm in sunny Portland, as I said, and Donnia, I'll have you introduce yourself, please.
Yes, hey, my name is Donnia Tabor-Hanson. I've been at this business for 30 some odd years. Known Sean about as long. And today we're going to be discussing some more of the Revit family conversations that I want to be having. Today we're on reference planes and shared parameters. Very exciting stuff today.
And you're also, some may know you as CAD Mama or many other affectionate terms. Everybody loves Donnia. And why do I keep calling you? I always call you Donnia. I never have to say your name. So I say Tabor instead of Tabor. What is with me? It's a mental thing.
Like
yeah,
labor.
I got. Oh, now I'm going to remember that one. All right. Well, let's go to the next slide. So everybody's line is muted. We invite you to turn on your cameras. Kind of gives us more of a, we're in the same place together, although we're not. So it's kind of a pseudo-physical environment. If you have a question, raise your hand using the Zoom tools. And this session will be recorded. A link will be emailed to all registrants and uploaded to the community conversation site. So again, ask your questions using your raise the hand. Lawyers always ask us to make sure everybody makes their purchasing decisions not on forward-looking statements. If I say, something magical is going to happen in the product, or Donnia does, don't do your purchasing decisions based on that advice. Everything is what is shipping in the product now. And Donnia is our Revit expert. I'm your Autodesk employee. Donnia's not with Autodesk, but boy, she should be. Anyway, next, please. So our community conversations are a way to provide opportunities for our engineers, artists, designers, and makers to meet in a safe, live, virtual setting, to share expertise, get to know leaders in their field, and grow your community network. It's open to everybody. If you have an idea for a great series, we want to hear it. So this is for everybody. These are community conversations. Let's have it at that. And with that, Donnia, let's get into bones and ligaments.
Bones and ligaments, yes. Our reference planes and parameters, as I say. Welcome to the second topic on Revit families in our community conversations. My name again is Donnia Tabor-Hanson. I will be sharing what I've learned over the many years using Revit. I've worked in a variety of fields in Revit, but no matter what company I work with, I always come back to the families. I always feel like that was some of the most interesting things that happened in Revit. How to make them, how to get them to do what the project needed. So let's get into it. Today's meetup flow, we're going to start with, for the bones and ligaments, we're going to talk about the reference planes. The ligaments, we're going to be talking about how to flex the family, and that's the family parameters and stuff. Then I'm going to talk about the family parameters versus shared parameters in the shared parameter file. And then I've got a XYZ parameters that I'll be discussing on giving some flexibility to your shared parameter file. And if you were here last month, I'm going to show that Dynamo, the adding parameters, that Dynamo. I'm going to show you where to go get the Dynamo. I had received an updated version of that, Dynamo video that I had. And we're going to have some Q&A and preview some upcoming topics. So I'm very excited about this. So let's get right into the framework, the reference planes. When you start with a family, most any family for components or for annotations, you're going to have two reference planes. They're the center front back and the center left right. And these two are also set by default to define your origin. Now, when you look at these reference planes, they can show that they're 2D or 3D. A 2D reference plane will have the pools. There's pools for each. There's a 2D reference plane will have a dot on it and it will say 2D on it. The red stuff is what I've added to this. So this is what happens when you select a reference plane. There's a lot of information given to you too by just selecting a reference plane. It shows you the pools, whether it's 2D, 3D. It shows you the name of the reference plane. And if you didn't know it, it shows you the negative and positive side of a reference plane. The name of the reference plane will always be on the back or the negative side of the reference plane. And we're going to show you how that makes a difference when you're building families. So keep in mind, this is a lot of things that some people have never thought about doing, but it does matter which way you draw a reference plane to get the front, the back in there. Okay. So we also want to add names to your reference planes. You don't just want to throw them in there. You want to give them names. And the typical names that we're going to use are front, back, left, right, top, maybe bottom or base. And when you go into name these, we also want to look at not just the plan view, but we want to look at the bottom view. So let's actually go over and look at one of those. Let's go find my Revit. And here I've got a typical family startup. I have the two reference planes that were in there. They are both pinned. And I'm going to draw some reference planes. So when you draw a reference plane, you want to draw it in a counterclockwise motion around the center of the object. So I would want to draw the right reference plane going up this way. And then we're going to continue across the top of the screen, doing the back reference plane. And you draw all four of these in that motion. Here's a little trick. I come over here, I go to the reference and I say RI. No, RI. I did that when I practiced too. I select right, I can copy and I can paste and give it the name. Make sure it has the same. Any named reference plane that is using these is referenced names will automatically be a strong reference. And we'll get into the strong, weak, and not referenced here in just a second. Come here and give me a Dynamo. Apparently my finger's not working with the keyboard today. Maybe it's a good thing I'm going to copy and paste. And let's go ahead and give this one the, now, come here, one more down. The front name. So now I've got these four are named. I can see that the negative side is to the outside of the centroid of the object that we're going to be building. When I go to a front view, I will also want to go in and name the reference plane that's on the bottom here. Maybe you want to name it bottom, but maybe you want to name it base. If I have an object that I'm going to be building that's going to have a top and a bottom of the box, let's say, and then there's going to be feet underneath it, legs or casters or something, maybe I want to have that to be bottom. So maybe I'll name this one base so that I at least have it named. I don't like unnamed reference planes. I want to be able to use them as they are. So I didn't mean to do that. I said I wasn't going to do that. I'm going to go this way, back over here. So let me go tab to get that reference plane. And I'm going to go ahead and name him base. You see his negatives to the bottom and positive to the top. Now, the other thing you want to do is you want to pay attention to those level lines. You want to pull them in And you want to do this in both front and back. And by the way, the annotation can be turned off. And the reason you want to pull these in is because they help determine how big how far out your reference planes go. I can't guarantee how tall these things are, but let me go ahead and add a top here so we have some idea of a box at least here. And let's go get top, copy and paste up here. Now I'm going to make this one, I'm going to do like a 24 by 24 box. So I'm going to go ahead and pull these in to give you the idea of what this thing about pulling in your level line and what a difference it makes. So I'm going to go ahead and pull this reference plane in here. He was drawn before I start pulling, but if I go get this reference plane and pull him in tight, this is going to determine how big the reference planes are going to stick out after I draw any more reference planes that are parallel to this one. So let me go ahead and pull base in here too. Now, that level is not going to change, and it does seem to be a bit bothersome in there. So go ahead and just turn his annotation off. He's not moving. I know where my level is. It stays right there. When I go to the right view, wow, you can see how big, and you can see exactly that top went the complete distance of where that reference plane is. So you can go and judge how big your reference planes are going to go, how far out they're going to go by how far out your reference planes go. So you may want to pull these in to begin with. And again, I should have gone here. And what did I say I was going to do? 24, 24. So I'm going to go ahead and pull this one in. And when you bring them in, that will be how big the reference planes will go when they're parallel to this plane. And if anybody can figure out how far to get them to stop at the top, please share it with us. I can't figure that out. I have researched, I've done everything I can. I put in a reference plane and call it top. They still go all the way up there. I can't control that, but I can control this. So now I'm going to draw another reference plane. That would be let's call it the bottom. And if I draw it, I can see I can come in here and be even with those. They want to line up with their friends. They see they line up with their friends. And let's go ahead and call this little guy bottom. And copy and paste. And when we go back to the front view, you'll see he stayed right in that area. He didn't go all the way out. So you have less time of manipulating, controlling your reference planes to get them in there where they need to be within your basic model that you're building. So that's one way you can help control your families, control your reference planes. Is give yourself a little bit of boundary. If you know basically the size, you get them started with that size, and then pull in those level lines and then go ahead and turn off the annotation. So like I said, that level line ain't moving, so I don't have to see the annotation for it. Okay, so let's talk then about this is referenced. So what is the difference between is referenced? And the default is for things to be weak reference unless you choose a name for them. The name ones are always going to be a strong reference. The back, the bottom, the etc. that we were doing. But you can also go and select for something to be a strong reference. And a strong reference stands out when you are dimensioning or aligning or moving or any type of editing. The strong reference stands out when you see them highlight in the families so that you can get to them. Now, a weak reference can also be tabbed to act as if it's strong. So if you're dimensioning to something that's a weak reference, you can tab through and get to it. Let's say you're there also is not reference. Let's say you're building a box and it has legs on it. The legs reference planes where you want them to line up, I would probably make them not reference. I'm probably not going to dimension to them. I don't care about those legs. They're there to support my box. My box is my family. Or if it's a column, I want to make sure that the column has got a very strong center, front, back, and center, right, left, because he wants to be centered on, that's a strong reference is going to be centered on the columns going to go on the column grid, and you want to be able to align to them. So these strong references, you can immediately grab and align to, move, dimension to, weak reference, you can tab through them. There is an exception to the weak and the not referenced. You can dimension to them if they have a distinct edge of an extrusion or something on that reference plane, you can dimension to that. Or if you have drawn some line work on there, you can dimension to line work, edges, strong. Well, actually it goes strong, line work, edges, weak references, and the not reference only if something is drawn on top of it that way or has an edge on it. So make your reference planes so that you use them the way that you need to, so that they're not overwhelming you with all the lines that you can that you get going across a family, which you see highlighting the highlighting lines that they do. Now, reference planes, you should have 2 in a plan view that determine your origin. This is your insertion point, if I could use the old AutoCAD term. This is what we call, this is where I want to place it. If it is going to be a column, I want it to be in the center, probably because I want to line it with the center of the column. It needs to be aligned with the column grid. If it is a shelving unit, maybe I want it to be the center and the back. Most of the kitchen, I'm in kitchens. If most of y'all may know that if you were here before, I do kitchen equipment. So most of my kitchen equipment, I will put the insertion point to be the back left. So you have to be careful because the original 2 reference planes are going to be the ones that are defining origin to begin with, but you can go determine which ones you want. And once you get the reference planes that you want to have defining the origin, you will want to pin them down. And you also want to unpin the other ones. When a reference plane is pinned down, you're saying, this is going to be my origin. I'm going to pin this one down, and I want all movement or growth to grow from that point out. So if I'm putting down the back, if I want this family to flex in length or depth, if it's in the back, then I want it to flex from the back forward. I don't want it to flex from the center. So therefore, I want to make sure the only one that is pinned down is the back. And you only want to pin 1 reference plane down per orientation, your left, right, or your front, back. That way, you don't, if you pin down the back and pin down the center and then try to make a different length or depth, it won't do it because you've locked down half of your depth. So you only want to pin down the origins. And by default, your level line in your base is going to be your origin in your when you're looking at an elevation. So we're talking basically about the ones that are in your plan view. So you always want to pin down just the ones that are being used for your insertion point, your origin, and to help all of your dimensions grow from that one plane. And be sure to unpin all the others. Yes, unpin the others. Okay, so well, let's talk about reference planes. And why does it matter if they have a name? Well, for one thing, name them helps figure out what's going to them. And what does it matter which way it's drawn? We're going to look at how the front and back react to us. And let's look at these questions. Let's look at these questions in a family file. Do we have any questions so far, Sean? Is everybody just hanging with me?
They're hanging with you, Donnia. I haven't seen anybody raise their hand or ask in the chat.
Okay, well then we'll keep moving here, because these reference planes, once you understand the rules of a reference plane, you're going to look at them very differently from now on as to how you use these and how you make things work with them. So I'm going to go over and compare 2 families. And no, I don't want to say that. I should have these here on my recent files. I want to get the one that is pulled, and I want to get the one that's not pulled. I took a family that I cleaned up for use with in my company, and where did it go? To pull. And I'm just going to bring these up side by side for comparison. So I'm going to window tile these. And let's just go in. One of the things you can do once you get your reference planes in, when you want to start cleaning them up, is you can pick on one, use your and isolate category. That's a mess. Over here, I can use my isolate category, and it's not as bad. I do have a lot here at the front. But like, look at this. What is this real long thing here? Left faucet hot. Oh, and it's a strong reference. Probably not going to need it to be a strong reference. If I look over here, this looks like it's back in the same area. Look here. There's your left faucet hot. It's pulled in very tight. It's not referenced. I'm not going to have to dimension to it. By the way, in this project, everything they had was strong reference. Oh my gosh. You be going along to dimension, it's hitting everything along through there. Or you can pull them in and where they need to be. These right here, this says it is the sink support left. And this is the sink left, the left of the left sink. Okay. Sometimes you got to figure out, this is the sink right. That's how I figured that one out. This is the sink rights left. So this must be the sink middle, sink center left. Yeah. So each sink bowl has a left and right. Okay, that was cool. And they each have a center. So you can see how cleaning these up makes such a huge difference. When I go to the front view and look at, let's go ahead and isolate this category with this one. It kind of begins to look like a sink. Over here, if I go to the front view, you can guess what's going to happen. Yeah, they're all up there. Isolate category here. So it's a world of difference in when you start looking at creating these reference planes and how you can make them work for you and how you can get them out of your way and look at it. It's like, I want to extrude something to which reference plane. I have to figure out which reference plane it is before I extrude it. Well, if it's generally in this area, I know if I'm extruding from here to here, I've got that reference plane in that area. In the elevation view, when a reference plane and the reference level coincide, I've always wondered, I'm reading a question, I'm sorry here. I've always wondered about whether it's better to select the reference plane or the reference level when locking geometry to or adding dimensions. I have a tendency to always use the reference plane in the elevation. I work with reference planes, and that's what I deal with. So it stays there. You can pin it down if you want, but I always have a tendency to work with the reference planes. I second the question. Okay. So thanks, guys, for putting that in there. I just happened to look over and check that. So yeah, that's why we use that. So in looking at these, I want to also look at, I'm going to just close these down. I also want to go look at why it makes a difference when you are looking at, let's get you a reference plane example family. Why it makes a difference in looking at which way you draw them and how they're working. So here I've got a basic little family, height, width, and depth. That's about it. I don't have much of anything else in here, but I do have here is a sweep. The parameters of the sweep it was drawn on the back family. If you know anything about sweep, you go to the sweep, you go into the front view, you go select, create, sweep. You need to set a reference plane. So this one had been chosen to do the back. I'm not going to do a sweep right now, but this one was on the back. But if I wanted the same sweep to be on the front, also, one of the things I can do is I can come up here and use the copy, paste the line to the same place while it's still highlighted. I can come up here and say, edit work plane. Well, what plane do I want to put it on? Well, I'll put one to put it on the front. And boom, I have a reference. I have it on the front reference plane. Isn't that cool? And even if I change the depth, it's going to go with the reference plane. So my depth is at 29. Let's go to 36, something that we can definitely see it move. Okay, but if you look real close, I see a bit of a difference. That is different from this. Notice that the sweep is going different. This reference plane was drawn in this direction. I can tell because this would have been the first front to the back. And this reference plane, not you, sorry. This one was drawn the other direction. So if you do this, see, it makes a sweep. The sweep even knows which is the positive direction of the reference plane, so it can make a difference in how it's used. So the way to do this would be go in here and Give me my suite. Edit the suite. And I'm going to go to the right view where I can see the suite. And see, on this one, I may need to, if it's an 1/8 of an inch up there, maybe I just need to move this down a quarter. And then I have both of them. Let me pull this one out. It says I moved it out. You can see they're now both going down. So see, it makes a difference which way a reference plane's drawn as to how a sweep looks at it. Okay, so while I'm in this view, let's look at doing, let's do an extrusion. And I'm going to do an extrusion. I'm going to set it to the left plane. I'm in the right view, so I'm going to set it to the left. Let's go way back there. Oh, no, go ahead and give me a rectangle. And over here in the extrusion, let's just go 4 inches. We can see it's on the reference plane is left. It's starting at 0 and ending at 4. And when I go into a front view to see that depth, I can see that this is going at 4 inches. Let's do that same copy paste thing to put it on the right. Copy paste to the same place. And then just edit its work plane and tell it to go to the right. And because of the orientation of the way the plane was drawn, the positive is to the inside and the negative is to the outside. So if I had wanted it to go to the outside, I just come over here and give it a -4, and I can make it go the other way. So this is one way that you can control things using the reference plane by the way they're drawn and how they're used. And once you learn some of these rules, it really makes a difference in how you look at how you draw them. I teach my team to draw the reference planes. If you are in a plan view and you need to draw reference planes, also remember if you're drawing along a wall, you want to make sure you draw it so that the outside of the reference plane will be along the outside of the wall. So you want to draw it in a counterclockwise motion as if you're standing in the middle of a room. So if you're using reference planes in families or in projects, they work the same way. There is a positive and there is a negative side to them. And just once you learn that, you look at them differently. Okay, so let's get back over here and look at what we're doing next. Preparing to flex the family. We've got the frame in there. And now we want to start talking about some of the ligaments and some of the parameters possibly. Some of the things that you're going to do is you're going to add your EQ strings on anything that you want to have equal. And you're going to make sure to check elevations for dimensions there. But please only dimension things like depth in one view. You only dimension like depth in your plan view or your right view or something, but only dimension it in one view. And you also want to remember that you need to name the reference planes. Name all the reference planes. And use named reference planes for geometry, like I was just showing you with some of those. We're going to look at some more here in just a second. And here's one of my favorite little tricks is duplication from zeroing out geometry. If you have geometry that comes down from the top, some that comes up from the bottom, if the top goes all the way to the bottom, you can't have that zero out because you can't have an extrusion with 0 depth. You could actually flatten out things and it will blow up on you. So I'm going to show you a trick on getting out of that. So in the case of, I've got a box that has legs on it, but I want the box sometimes to sit on the counter, but I don't want it to have legs. So I can, instead of just turning legs on, I need to be able to, so it sits down. And then we're also going to look at setting up some subcategories for your reference planes so that you can use them in a little bit different manner and make them stand out for you. Okay, back over to the same family we were in. And now in naming all the reference planes, I've got a reference plane down here, top of legs. Okay, now if this is my height and this I have locked at 30 inches, so my box is going to stay at 30 inches. Whatever this is that I'm playing with here is going to stay at 30 inches. I want to make sure that this is my leg height. So let me give him a name. Leg height. I'm also going to introduce you to a formula, and I've got plans on one of these community conversations to have some of my favorite formulas and stuff in it, but this is going to be just a quick one right here. And this is one of the things that I said about duplicating sometimes so that you can have some more flexibility and not zero things out. Because if the height of this goes down to 30, what's going to happen to my leg height? So let's go take my height to 30. And nothing happened to my leg height because I have another reference plane. Let's take my height to 32. I snuck in a reference plane here on you. I duplicated one on top of the other one, but I put one as bottom box, and I made sure to get the dimension that was the 30 inches that I was locking, go to the bottom box, and I have my height for my legs going to a different one. So my formula would be that anytime, legs should equal height, HT, minus 30 is what my legs should equal. But that is only if height is greater than 30. Height is greater than 30, then let's put the legs at 4. Else it's going to equal the height minus 30. So right now, did I do that right? Height is greater than 30. Then no. Height is less than. What am I doing here? Height is equal 30. Equal 30. That's what happens when I didn't write this down. Height. So then it goes right down to 2. If I change my height to 36 and apply it, the legs are going to go to there. If I change it to 30 and apply it, my legs stay at 40. So anything that it was an extrusion in between there would not get flattened out and give you an error message. How did I come up with that? Well, yeah, error messages. Flattened me out one time. So there's a nice little trick to have that. So now let's look at something else. If I want these sweeps to go in the middle, let's say I want to duplicate, and let's say I just want to move it. Edit work plane, front, center, back. That's the only ones I've got. Why? Because this reference plane says click to name. Click to name is not a name. Mid front. Now, if I want to move this back now, edit as work plane, mid front is now an option for me.
Hey, Donnia.
Did I not pick it?
Formulas is definitely a hot topic, it sounds like. There's Jamie said I could use the lesson on writing formulas for sure. And Gregorio said, are there formula cheat sheets available? So you definitely hit a gold mine there.
Yes. Yes. I love formulas. I had one formula one time that I swear if I hadn't had a second monitor, I'd have been in trouble. I mean, I stretched it out over here. It was quite unusual. I use formulas to turn things on and off, to change lengths, depths, heights, array formulas. Yeah, that's going to be a fun one. Matter of fact, I just did a family yesterday that will come in very handy, because like an array formula, but what if the array only has one? Arrays can't have one unless you have a sneaker hidden extra family in there that you turn off the array if it's greater than, yeah. Okay, that's a rabbit hole. Let's come back. So yeah, formulas are something that I'm going to be coming up on. I just know for sure, because that's just too much fun. No, I don't want to say this. Let's get back out of there and back over here. So let's talk about family parameters. Then we're going to get into the shared parameters. Family parameters, you would go and you would add a label to. If it's a dimension, it's very pertinent. You add the name to it. You decide whether it's going to be a type or an instance. So most dimensional parameters can be family parameters. Now, like I say, you choose their type or instance. They will fall under length and under group dimensions automatically. And once you get these things set, you get your depth stuff, your depth, your height, your width. You want to flex the family just to make sure, and you can do this before you put any extrusions on there. You want to flex the bones of your parameter of your family to make sure that those parameters, the ligaments, are making those bones work the way they should. So you will use the basic height, width, and depth, and you name them that, because the word length may not be a good idea to name something length. I fell into that. When I first started doing some families, I would do a shelves, and they had a depth, a height, and a length. Well, height is a length, depth is a length. It even says parameter type is a length when it comes up to, when I pick a dimension, this is what it comes up, automatically says it's a length. So don't choose the word length as being the name of your parameter. Make it what it means, height, width, and depth, for example. And then once you get those parameters in there, you want to flex the family. Go in and change them around and let flex the family. Every time you do something, flex the family. Add another parameter, flex the family. If it has anything to do with moving those bones, using those parameters as ligaments to flex the family in between. So in last month, we talked about building a family template. And usually with a family template, this is the basics of what I have. I have a width, a depth, and a height. That's all the parameters. Notice also I pull my reference planes in and I turn off my level line annotation and stuff, and I get them all set up and nice and neat. And this is what I would stop at if I was setting up a template like we discussed last month, so that I have the basics in there. If you want to add other family parameters as needed, you go up and get the family parameters, and then you choose your family parameters option, and you choose that. You can add its name and give it a name and choose type or instance and select the discipline if needed. Most time, everything I do is common. I don't get into most of these others unless I'm doing something with the electrical, but usually I use shared parameters for those. These are so if you are doing just family parameters that you're working with. And then when you get through that, flex the family. I'm gonna go through this, and then I've got a place for questions. I'm gonna look at this here and just say, they're distracting me. I want to do that now. Let's get back to this. So you choose the type of parameter, and if you're choosing, this is not a dimensional parameter, but you're choosing a type of parameter, you're going to determine what type of information is going to be input into the parameter by selecting its type. And once you set those, like I said, dimensions will always want to go be a length. So you choose your types of parameters. It tells you what you can add in there. Now you can group your parameter. This determines where the parameter is going to show up in the list of parameters for instance or type viewing. So you can determine where it falls in your if it's an instant parameter, you can determine where it's going to show up over here. And some of these group parameters can be changed, like to where you want them to be. Let me go out here. I group some of my things under other. My team knows that I will put things under constraints in the instant parameters if it's something I want to let them mess with. Turn the casters on or off, change the door swing, something like that. I'll put under constraints, so they know that I put almost everything under constraints that they need to mess with. But sometimes if you have a formula that's an instant, it has to have an instant parameter to answer it. I don't want to put a formula under constraints because it grays out the parameter. They're like, why is it grayed out? I can't get to it. I can turn casters on, but I can't turn legs off. Well, the formula in legs says casters on, legs are off, so I put the formula under other for legs on, which says not casters on. And so therefore it's down under other. And my team knows under constraints, this is your playground, this is your sandbox, go play in here. If it's under other, it's for somebody other than you to mess with. See, That works for me. If it's down under other, it's for somebody other than you. So don't mess with the ones under other. All right. So now would be a time to look at some of these questions. What are tips for flexing families with sweeps? Lock your sweeps. When you have your sweeps perimeter down, it should be locked to reference plane and let the reference plane move it. And so they're not tied to a reference plane appropriately. I read the rest of the question. Yeah, that will do it. If it's not tied to the reference plane, everything, your bones are what moves things. So if you want something to move, you've got to lock it down to a bone. You got to lock it down to those reference planes. So once you start thinking about that idea of these reference plane being your bones, it makes it easier to work with them and keep that in your idea. And someone posted the Revit form show thread, Revit formulas for every day. Okay, we will put that. It's an oldie but goodie, says. Who put that? Benjamin. Okay. Benjamin, we will put that in the chat for the this conversation today, the community conversation. There's a chat area. You should ping on it if somebody put something in there, but it's a great place for us to add things like that in here. So there's your formula cheat sheet. And what was this last one? Create a subcategory for the reference planes. Yes. I said I wouldn't do that. I did it twice. Let me go back over here and do that. And thank you for bringing that up. I meant to do that. If you've got reference planes here, and these two are going to be not referenced, you can go into, under your Manage tab, go into your Object Styles. And we usually see this, and then I usually go over here and make sure I have no CAD in there. But you can go into your Annotation Style, and you can add a new subcategory of typing, not my forte, not reference, and it's a subcategory of reference lines. I want to probably keep it with the same line type. I like them all the same line type, but maybe I want to go pink. By the way, I found that green is not a great color for reference planes for at least one of my team members. Every time I open a family she's worked on, they're all pink. She's colorblind problems, I think. Wait a minute, didn't I have that in there? I didn't hit save, I bet, did I? Fine. Create new subcategory. Do it this way. Oh, wait a minute. Oh, I put it in reference lines. Yep. Need to make sure I'm under the right category. Not referenced. Rinse and repeat. So now I could set all my not referenced ones to be one color, my weak references to be another. Someone put in the chat where the quote, where the reference, the things, the links will be placed. So that's good. That's distracting me. So yeah, you can make it so that these things stand out to you a little more. All right, looking at our time, I want to get into the share parameter. And because I want to have time to show you the Dynamo too, just where to get it and stuff, but okay. On the Manage tab, you may have to go find your share parameter file if you haven't found it. You do need to check with your VDC or BIM manager. This is the parameters that are going to be in tags, but you also, okay, tags, schedules, and tags and schedules. You need to make sure you have permission to edit this, and in our company we prefer that nobody edit it, and this file you need to find out if it's right protected or not. So we have made it so that we can do this. Parameters that need to be scheduled, tagged, or appear as labels have to be shared parameters. So those are the ones that have to be in there. Check with your company before you go editing your share parameter file to make sure you have permission. I will show you how we get around some of this by using some of our XYZ parameters. I needed to speed up a little bit here. Okay, some parameter groups may not make sense. For example, if I go get the electrical connection RI height, it goes under dimension because it's a length. Well, I just change it. I move it to the electrical group. You can do whatever you need to with these to group these the way you want to. Now, my XYZ parameter, this is the answer to the family builder that is not the BIM manager, the family builder that has a customer that needs some special tags or things in their schedules and stuff. This was me that had to go to the BIM manager of Tormark USA, where I worked years ago. And I said, I got to have more. I've got a customer that they asked for more. So I came up with this idea of XYZ parameters. It adds some flexibility to the shared parameter file. There will be some that you need. So we call them the XYZ parameters. And why XYZ? Because it shows up at the bottom of the list. You got to know what you're looking for to find it. The XYZ parameters, let me go back here. We started with some of the basics. We have integer, length, number, angle, volume, things that we text. And we started with 10 of each. We have 10 of each one of these parameters that we use and that we've set out there, because there's going to be people that are going to want a different parameter. You know who you are. The ones that say, I've got to have it. You know who you are. So we give them the flexibility to have these. Now, if you're doing these non-traditional shared parameters, you want to make a list of them. This is the list for that one customer. These are the different shared parameters that were used and what they were used for. We kept these on a OneNote so that anybody on the team could go see it. And anytime they knew, some of these were used in formulas, some of these were used in tags, some of them were used in, here's mock sync sheet numbers. They had to be shared parameters to put these in there. So we gave them the opportunity. And you could use several more time. I use like integer 3. Well, I used it, integer 3 set to 3 will do this. Integer 3 set to 2 will do this, whatever you need it for. So you can determine how you want to do this. Now, if you use one or two of these in a customer project, you may want to take note of these. Text one parameter used for customer custom call out for equipment. And we have a place on our title block that says project notes. So that's where you want to put these down there. A potential issue with custom subcategories, they will carry through to the project when loaded. So be sure you use names that don't mind having in the project environment. Yeah, you need to they should be logical names, and you shouldn't be naming things like, I had one guy that used to name things after himself. So it was, everybody had different names for things. It was the weirdest thing. He kept putting his first name in front of everything.
Your flyers.
Well, okay. Working from home. Yes. So now let's talk about that Dynamo. That Dynamo that I previewed last month, that would add share parameters. Get your screen capture ready. You're going to want this stuff. It's by the Aussie BIM Guru. And you may want to screen capture this. I will be putting his information in the GitHub. He has a new package, and Gavin Crump is his name. And he sent me the newest version of the 2020. When I asked him, I said, I'm going to be presenting this. So I shared this with him. And I said, what do you want me to put out here? So there you can find out how to follow him. And these are here's another screen capture, although I will be putting these links in the chat for the session. The add share parameter files, there's a new one in Dynamo 2020. I'm not using that yet, and it's only because in my profession, I have to build to the lowest common denominator. I'm still building families in 2018 because I don't know what projects are going to be there, and I can always bring them up, but I can't bring them down. So I've not moved to this 2020 yet, but I can show you. So here's how it goes. You're going to create these dynamos. He's going to teach you about how to do your schedules with Excel. And you're going to get all your parameters listed in Excel. And he says to put them in alphabetical order. I've got a master one that has every parameter in all my schedules. And then I can take and pare it down by doing save as and take, okay, then I have the electrical or the electrical with gas and whatever I need. I've saved these down. And then I created a document for these packages, because I want to keep my team informed of where these dynamos are and how to work with them to empower the team. Now let's start with, I'm going to go show you the Dynamo. Let's see. No, I don't want to save changes to that. Let me get hold of this guy. This is one I've actually got to fix. He's upgrading. These are for the families that my team goes and gets, and you want to bring them into the family, so you got to get the adoption papers filed and everything. And I want to make sure that they have all of our parameters on it. So I'll go look here, and it looks like I'm going to need gas. I'm going to need some of our custom parameters here that we use for our schedules and our tagging. So I'm going to go get does Dynamo close on you? I had it open. I'm going to go get Dynamo and bring up the two versions. While that's coming up, let me show you my Excel files. This is the Excel file that I used his YouTube to develop for my previous 2020 version. His 2020 version of the Excel file, he has some headers on it. He also he put some lists and stuff that you can pull from on a second sheet. He went a little bit more into detail, but he will tell you in his YouTube how to create these, going into parameter names and everything that you need for running these dynamos. So this is the 2020 version. Like I said, I've not used this yet. It's a very pared down version. It goes and gets the Excel file, pass it through, adds the parameters, and pushes them out. Basically what you want to do, I want to add these parameters. Now, if those parameters are already in your family, it doesn't matter. It just goes over them. So I'm going to go to the one that I'm using because I've not moved up to the 2020 version of it yet. I have it showing up directly right here, and I need gas. So right now it's looking for electrical, and I'm going to show you the entire thing here in just a second. I'm going to go get my gas parameters in my Excel file that has just the gas. And you see, this is the other version. Snaked out all over the place. It got narrowed down into one. He found a node that would do that. I want to go into the output. This would crack me up just because it did. Now, when I hit run, it's going to add the parameters for gas, add our custom parameters that we use in our schedules, that also we use in our view templates to help color things. So we have things, and if it added it, it comes in here and says, yeah. And if it had to add it, it says, oh yeah, baby. Somebody had fun writing this one. So once I get that done, then I can go in and I can, yeah, I never save these. I can go in and see that my parameters, I'm looking specifically for some of my parameters that were added, which includes the TM utilities, and gas would be set to 1. It's just a company thing with ours. It helps to isolate it in our plumbing schedules and to give it a color coding in our view templates for our working views and such. But that is how you add the parameters. And with that Dynamo, I also created for Trimark, I added I'm a trainer. I can't help myself. I set up how they go about getting the Dynamo, how they go about adding in the nodes that it needed, how to install it, checking what version they're on, etc. And then down to the first time they run it, I have them run it through Dynamo, and they go and they get the parameters. They go and they select their input. They pick out their Excel file. After that, they go through and they have another one that will turn the parameters, that will set some of the parameters to the values we have it. When I get done with everything, I said, well, now once you run it the first time and now you know that everything runs, you've got the nodes loaded. Here's where you can go and do it with the Dynamo player. And I think most of them, once they do it the first time, will go to the Dynamo player ever after. Now, I don't teach Dynamo, don't want to teach Dynamo, not ready to teach Dynamo, but I do recommend Crump's, he's the Aussie BIM guru. I do recommend that you go and look at things that he has there. The example of when I use it the most is when they, like I said, when they bring me a team member brings me something that needs to be adopted. So to get it adopted, I have to clean it up and give it our parameters, put a little shirt on it, says, I belong to the TM families. Now, Q&A. Do we have anything else?
We do have a couple good feedback. I especially like the commentary that somebody was having their parameters named Ho Ho and Holly for Christmas. That's very helpful for me because I have a very basic level of Revit. But we got other people have answered questions in there as well. If there's
Okay.
anybody that had their hand raised and I missed it at any point, throw it into the chat or raise your hand again. I'm watching all the different
Hi.
tiles.
Hi, Heather.
Hi, I'm Heather. How's it going? Thank you so much for this. It's one, you're just super fun and it's super educational. So thank you.
Yeah.
I have two questions. One, can we, if we do have time, discuss a little bit more about arraying again for one where they're all in the same place, and then scheduling that. So I guess the family I'm thinking about specifically is I work in bicycle retail. So we have like one hanging bike or multiple hanging bikes or like wall fixtures of the same kind of setup, but we want to be able to schedule those as well. So
we can put that on the radar for when we do, arrays is one of my specialties. I love arrays. I will do a stovetop that has, give me a range, and I've got 4 eyes or 6 eyes or 8 eyes, and then they're like double row or single row.
yes.
So I just did one that had, you could do single or double row, and you could do multiples.
Perfect.
So
Yeah,
that was really fun. Yes. So yes, that's definitely on the radar. What was your other one?
And my other one is clearances. So when you are labeling either clearances that you either want to make sure that you can dimension to, or you just want to show a customer or a client where the clearances are, but when you're like moving around in the model, you don't want to actually touch those clearances because it gets bothersome as you're, do you know what I'm kind of getting
We
at?
use clearances all the time.
Perfect.
You got to understand, in kitchens, you have to have clearances for doorways or they have mandatory clearances on the sides, have to do with heat, or, something for, maybe you just need some service clearances and stuff. We do all of our clearances as an extrusion. And that way we can have it show up, and we only have it show up in our working view. So we have our people give them the clearances around, but then we turn them off in our print view. That's just our preference. You could have them where they show up. And generally we have them show up as a dash line in your plan view so that you can see where the clearances are when you're setting things up. But having them as an extrusion also allows you to do clash detection as opposed to just line work.
Okay.
Great questions.
Can you explain that a little bit more of like versus just the last part?
This clearance is an extrusion.
Yes.
So that's not part of it. That will be turned off in plan view. This is an extrusion showing where how far the drawer is out. This is a mandatory extrusion. There must be a tray that pulls out into there.
Okay.
So in plan view, I'm back here. I did not build this family, and I got to clean them up. Our disclaimer right there. Our extrusions are set so that they don't show up in fine view or coarse view. We only shows ours up in medium view. So our working views will show them up and show the extrusion. And even the line work would be set so that it has a visibility of only showing up. I haven't picked, ours is in medium, not in coarse.
Okay.
So we do that way so that we can have a working view template and a plan view template.
Perfect. Okay, great. All right. That's awesome. Thank you.
Sure. And I see we're coming up on the top of the hour. Let me get to these last slides. There was a lot of rules. Love that Dynamo stuff. If there's any questions left on the table, you know where to put them in the chat area for this session. Grab your screen capture again. Next, we're doing building with muscles. For Revit families, we're going to start looking at putting some extrusions and sweeps and stuff on them. And then we're going to talk about materials and how to put some skin in the game in July. Other topics coming up are catalogs and library prep. Favorite fabulous formulas for families in Revit. I had fun with that one. And testing your Revit families and the home wrecker. You need to know who the home wrecker. Some of you know who you are without even me describing it. They're the ones you send the families to once you get them built to have them tested. And don't forget the other topics in the community conversations, and that's the list for that. And I will turn it back over to Sean here.
Thank you, Donnia. That was awesome. And I actually learned a few things here. It's always a pleasure, and I'll just put it out there. I love you. I always have. So we'll wrap this up with today's session with 2 final slides. If you're looking for ways to connect with the Autodesk community and engage, we have a few resources for you. So I hope you'll continue to stay connected with the Autodesk community. And like Donnia has said, Go into the discussions after this. Keep this going. There's a wealth of knowledge that goes on after these community conversations. So thank you for participating. Some of these other resources are up on the screen of the Autodesk Group Network. Oh, it's fine, Donnia. Industry-focused communities, our Autodesk forums. We've got Facebook forums. We got our Twitter handle. We got lots of resources. Make use of all of them. They're all there for you. That's what this is about. Community is not just us. It's everybody. It's Donnia, it's me, it's Kate, it's Rachel. Thank you, everybody. There's going to be some pasted links in the chat. And so please stay involved and engaged with these and the community and these conversations. Thank you.
Thank you, guys. See you next month.